Okay. Hi, everybody. Hello, Alessandro. Hi, Patrick.
Hi. Hi.
Okay, so we are 30 attendees at Montpellier, but we are sorry because we should work more than 10 minutes to go to the lunch and come back. And people now they just leave the restaurant to go back. So if we can wait 10 minutes more, that will be fine for us. Sorry for this. Thank you.
No problem.
And after, just to inform you, after we have to finish. We will try to finish at 3 p.m. because we have an event after to take a bus to go to a city near the sea to make a walk until the night. You should come at Montpellier.
Yes, sorry. How is the weather?
Very good. It's
Okay.
Sunny.
Okay, you're lucky. Okay, good. Good for you. So, Patrick, what do you think? We can leave 5 minutes at the end for the questions. Tell me what you prefer.
Okay, yeah, 10 minutes, I think.
10 minutes.
I will try to speed up then because I do have quite a large number of slides. So, but we'll see, and I'll try to skip some things if necessary. So, but please feel free to remind me if the time would progress very quickly. I think I have 55 slides. So, but some of them may take more than 1 minute for sure to explain. So I'll try to speed up, but feel free to step in and point me at the time that we are using.
Okay. If I want, I can give you a reminder at 2:30, so that more or less in the middle of the presentation. What do you think?
Yes.
Or just perfect. At the end, what do you prefer?
Oh, no, it's fine. Halfway is fine. Thank you.
Okay.
Non, là, tout est bon. des nouvelles ou pas? Oui.
Quand je suis partie,
C'est où dans un restaurant ou tu les vois? Tu les as vus arriver? Ah. What about yes, there's moving right? Slowly getting in. Okay. Ouais. So the people start to arrive in the room. So I propose that Patrick, you can share your screen if you want, and in a couple of minutes, Alessandro, sorry, you can introduce the speaker.
Okay.
Hi, Alessandro. I'm good to go.
Okay, thanks. Okay, so good afternoon to all of you. I'm Alessandro Piva. I'm the general co-chair with William of this edition WIFS, and we'll introduce our speaker, which is Patrick de Smet, that he obtained his PhD in computer science engineering at Ghent University in 2002, working on image and video segmentation. Then he started to work on forensic ICT techniques and other investigative computing technologies. And in 2005, he joined the Belgian National Forensic Science Institute, where he continued to work on tools for image and video analysis, for image and video enhancement, and forensic data recovery and repair of damaged multimedia data. He is also a member of IEEE and of the IEEE Computer Society, and is currently chair of the Digital Imaging Working Group of the European Network of Forensic Science Institutes. And finally, is also involved in the European Uncover project dealing with steganalysis. So as you can understand, our speaker has a wide, strong know-how on all the aspects of multimedia security. So I am sure that his talk will be really interesting. So thank you very much, and I'll leave the floor to you.
Okay, thank you very much for the introduction, and thank you, IEEE, and the organizers for inviting me to this presentation. I'm really honored and happy to be able to do this, as I will explain also later on, I think. So if you don't mind, I will stop my video just now. I just wanted to show my face, so to indicate that I'm not any Lenny chatbot-like person that is supposedly giving this talk. I'm a real person. So let's get started. Okay, so maybe just before we start, just a quick bio. I'm not going to dwell too long on this, as I was already introduced by Alessandro. But I think it may still be important to highlight a few points, because I always believe that there's always bias or background that creeps into some of these things, particularly this kind of presentations, as I'm sure you will notice. So just a few words. So indeed, I was graduating from Ghent University. I worked on image and video segmentation, and then I moved to the Belgian National Forensic Science Institute. So we are a government organization resorting under the Belgian Ministry of Justice, and we do research as well as actual casework. So we are being ordered by magistrates to investigate certain criminal cases. What did I do there, and what am I still doing there? Well, I started with various things. I worked a little bit on automated document reconstruction. I worked also in the beginning, especially on white light profilmetry, so it's measuring surfaces, for which you can see an example here. So measuring the cracks on a certain blade or knife, for example, or things from ballistics. Then some image and video enhancement, which was a nice chunk of work and still is part of the job. Some 3D laser scanning. And then, of course, the most interesting topic for today, I think, is the actual data recovery and repair, so more digital forensics oriented. So as I said, you will definitely notice some bias in this presentation, but I hope that you may also learn some things, because I do want to share some ideas and comments on our field with you, and I'm most happy to receive any feedback you may have. So some more disclaimers. This is just my personal opinion, not any formal opinion from my institute. But that being said, I also still want to highlight a little bit that now I'm working in this forensic institute, and it's a little bit in between academia and law enforcement. We have respect for anyone working in any organization that is involved in digital forensics, but our institute is a little bit specific because, well, we are having a look at both those different sides of the problem. So doing research, more fundamental, as well as trying to apply it on real cases, trying to arrive at a single button click solution so that everybody could solve cases quickly. I will present a very short state-of-the-art overview. For sure, it is definitely incomplete. Well, as I said, I'm honored to be here, but I think as most of you are probably in academia, I think you would already have a much better overview of the state of the art. So please feel free if you would have any comments or suggestions to make during the talk or later on. Yet I do also want to make this point that you will notice that later. I think that there is a lot of work going on, which is sometimes under the surface. And I hope, I really hope that most of what I will talk about, that you will already be aware about it. But I do also notice sometimes in discussions and communications that some of the things are not known. So I thought it would be a good idea to point out a little bit what expertise may already be present without being known to the outside world. So some philosophical notes, also a little bit of advertising, hence the reference to the bias and that I already made. And maybe, if you like, also some suggestions for possible future work, because there are so many things, as with any technical field, I think, but there are so many possible things for future work that are there that we simply cannot manage or even get started on doing them. So maybe, hopefully, you may pick up some ideas and help us to achieve some advancement in our field. Some more disclaimers. I think I will repeat that later on. We are not going to talk about anything related to hardware, multimedia, data recovery, or anything that's has to do with electronics or anything like that. Yet it is obviously a very important sub-area in our field. And I will maybe return to it a little bit later on, just to point at some things, how they are related to each other and how they may still offer avenues of future work, which is all related to software-based recovery that will follow later on. So, as I already said, maybe this is not really a keynote speech, maybe this is more like a tutorial. So I hope I will not annoy you with too many things that you already know about. Hopefully you will learn something, and if not, any feedback, positive or negative, is most welcome afterwards or during the talk. Okay, let's get started then with the real content of this presentation. So we'll start with a brief introduction on forensic data recovery in general, but later on I will then obviously focus on multimedia data recovery and repair, with a big focus on image data and video. So a quick review of state of the art. Then I will talk a little bit about some of the R&D and the tools that have been developed by law enforcement agencies and forensic institutes across Europe in particular. And I will also try to indicate a little bit how this data recovery subfield, how that is used and interacts with the workflows that we have in real casework. And then, as I indicated, some future work, probably throughout this presentation, and some final comments. Okay, a quick introduction on forensic data recovery in general. So, of course, we're talking about digital data, and the way we often like to think about this problem as a whole is, well, approaching it a little bit like ISO or IEC does for network stack. Well, consider it a stack of these different digital technologies and try to find out which methods you can apply where. So, as I already indicated, we are going to talk today mainly about software-based data recovery. So that assumes that you will have a proper forensic copy, as we say, or a data dump of an electronic device. So a low-level copy of all the information that is stored on your hard drive or your mobile phone or anything like that. So traditionally, a lot of persons talk about forensic image, but sometimes that can be confusing. So we prefer to use the term data dump to indicate more clearly that you're actually talking about low-level copies of devices. So although I said that we will not fully focus on the low-level stuff, so no real physical device issues, not how this data is being interfaced with, but more about what are the file system issues, what are some of the data file issues, so the containers and the content that have audio and video, and maybe also a little bit, we do touch upon some interfaces between these different lines, so maybe a little bit about the decoding part of it, but not in full detail about the actual display or use of multimedia. Okay, as I already indicated, I will try to focus on some multimedia recovery issues, but I do think that it is important to, for a moment, stand still and have a look at the digital forensics issues that are definitely involved. So the file system that we are using on all our storage media. So let's just very quickly go through this. So suppose that we have a linear representation of the data clusters or blocks that we have on our devices, and that some information is being stored in those clusters or data blocks. So we have, for example, 1, 2, 3 blocks, and we continue to 4, etc., etc. So a linear representation. In each of these blocks, there is information being stored. And of course, we also store somewhere some metadata. So we have a different number of files with their file names, Jedi Story, NASDOGI, etc. And the file system that we are using on our device obviously also stores the location to be able to actually read and access the information stored on our device. Now, the big issue is that in some cases, this information can be fragmented. So that means that not all data blocks or clusters of your data file will be stored linearly. They may be spread across the surface, actually, also physically, of your storage device. So, for example, in the picture you see on the screen of this nice dog, let's say, from the Never-Ending Story movie, is being spread in 2 different parts, so 2 different fragments. So that is not so difficult if in our everyday use. The file system will take care of that, so it knows where to find the different blocks, and if we just want to read the file, it will immediately read out this metadata and be able to have us access the entire picture without any indications of how these fragments of the data is being stored. Now, let us maybe simplify a little bit, because there are many different aspects that can be involved here. And let's assume that we are going to look at the common case being a standard Microsoft Windows PC. Although, as indicated, mobile phones are a major issue in forensics nowadays, as we all use them very often and very diverse in terms of different operating systems, etc. So let's consider a USB stick, which has the file system. And again, we assume that these files are being stored on there. We have all the metadata, etc. Now, one of the things that can happen is, of course, that we will delete a file. And what actually happens then, of course, this is again an oversimplification, but in the FAT file system, the first character of the file name will be set to a special value, hex E5, if I remember correctly. And what may happen, and that's an important point, is that also the ranges of where the data blocks or clusters are stored, that those will also be set to 0, erased, or not. So it already indicates an important point that some of the things that are involved in this field is that you are depending on details. You're depending, in this case, on implementation details. So how does this file system actually work? So that also means that if you look at a simple USB drive being formatted on a Windows PC or on a Linux system that formats the hard drive when you receive it from the shop, if that is necessary, then you will notice already some differences from the very beginning. Let's not dwell on that. What is the main thing that we should remember from this is that there are many tools that allow you to recover files in this context, because as indicated, only the red crosses indicates some information that's lost, but most of the information is still there. And there are some recovery methods who will allow you to still try to reconstruct the original file although it was supposedly deleted between quotes. The thing is that, again, we already see an issue here. Some of these tools work differently. Some are smarter than others. And there is also no standardization in terms of terminology for all the different possible situations that may occur in these fields. So that makes it also difficult if you would like to compare or join results from using different tools. You already have to juggle a little bit with even the definitions of certain types of recovered files that you may find. All right, so what is now basically missing? Well, that's another assumption that is often made. If we start to work on recovery in forensics, we often assume that all the files that we just see appearing in the directory tree or that we try to extract, that they are all sound and correct. And so we sometimes often transplant that in if we try to apply these simple undelete tools. Well, maybe it's a good idea to not always rely on what these tools would do, obviously. And just as an example, let's have a look at PNG images, so lossless compressed images. I hope you all know this standard. Well, there is this tool which is called Png Check, which allows you to check if a certain image that you have, if it really conforms to the standard. So that tool is the first aid, let's say, to check if you are going to work with recovered data, if this PNG images would be indeed correct or not. Well, it turns out that this is not always the case. So in 2016 and now, and maybe also later throughout the presentation, please have a look at some of the years that may be indicated, because that's one of the points I will return to later. So we had a look at a large set of PNG images that we just randomly downloaded, and we had a look at if they would indeed be all correct according to this automated checking tool. But it turns out that 1.7% had errors. So please try to remember this slide, because I will return to it in a few minutes, I think. So it can prove that the devil can be in the details, and you always have to check some of the assumptions that you are making if you are indeed trying to do the best job possible in recovering multimedia data. Okay, this is a slide with a lot of text. Let's maybe not go into detail too much here, but what is the main point that I'm trying to make with this slide? Well, as already indicated, I guess, is that there's a lot to understand, there's a lot to know, and there are some things that have not yet been fully understood or studied in detail. And there is a lot of possibility, I think, as will be indicated later as well, to try to merge or improve some of the tools that we have. Okay, so far I was talking mainly about using file system metadata. So either we had active files, so files that you could immediately read by just accessing the file system as it would appear if you would just use the storage media on a device as you typically do, or you could try to undelete, so try to use some of the remaining metadata to try to recover some of the files that may, or the file information that may still be there on the device. What should you do then if you cannot do that? There are various possible reasons. So you could have all kinds of loss of information for any possible reason, maybe accidental, or it may be on purpose, somebody trying to quickly erase some of the data while his house is being raided, etc. Now, this poses already the general question. If you look at some of the things that we are going to discuss in what comes next, what is going to happen if you would partially corrupt on purpose or by accident some of the information that you may have? So there is still a lot of work in that area possible, I think. but I hope that will become more clear later on. So the question is basically if we can already extract files by using the active file system or doing a simple undelete operation, what else needs to be done? Well, we have a lot of free space or unallocated space, as it's called, in which we can still look blindly for any remnant data that may still be there. So if, as long as it has not been overwritten or let's say shredded on purpose with a specific tool, you may still be able to recover a lot of files. And that is obviously something that could deliver a lot of evidence in the end. Good, so the base techniques for doing this, so analyzing any free storage space that you may still have is called file carving. And how does it typically operate? Let's again return to our storage media, so a hard drive or an SD card or USB drive, it doesn't matter. And we represent each of the clusters or the blocks on that device as a single square, shown in the top of the figure here. The most simple approach to try to recover some files from this data dump or from this data device is by just scanning through all the different blocks and looking for a known header and footer of a specific file format. So as I hope you will all understand, there are a lot of different formats which have typically a 4-character code which indicates the start of the file and then possibly something that indicates the end of the file. So the most simple approach to try to look for remaining data on your device is just scan through your entire storage device. If you find a header, you assume that you will have found a file. You scan all the data until you find a footer, and then you say, okay, I have recovered this file between the header and the footer. Now that's all fine, but as we have just discussed, this does not work if you have, of course, this multi-fragment situation. So if the file is spread across different fragments across your storage device, you may have some trouble in recovering this information. We'll return to that later. And then something which is a specific case of this carving is if you have an embedded file. So that means, for example, if you have a JPEG image that is being used in a Word file or in a PDF or something like that. And again, I think this is something where we have not yet seen too much research on. And it's a little bit sad because obviously the more information, context information, let's say you have, the more it could possibly help you to try to recover and reconstruct the entire data file that you are looking for. Okay. Now, what is one of the problems with this simple carving approach? Well, as indicated earlier, we can make this linear scan and just output anything between a header and a footer that we have found. But actually, this does not always work. So consider again now at the bottom a multi-fragment situation. If you apply the simple scanning algorithm, then you would output as a result of this linear scanning the entire red arrow. Now, obviously, this is an incorrect result. Why? Well, it's obvious. You will output first the file that you think that would be a correct file, so everything between the header and the footer, but clearly that's not the case. You have included additional information indicated in red, and so your base file will already be corrupted. Then it's even worse, so you have some kind of error propagation that occurs because you will also lose possibly the information that is indicated in red. So if another file would be in this first red area, plus file 1, you will lose it, or you may lose again a part of another file, etc., etc. So as indicated, it's some kind of error propagation. So if you are able to do multi-fragment carving correctly, it will also improve not only, for example, JPEG recovery, but it may also improve other files, other types of files that you're trying to recover. Now, obviously, this can be improved upon with a very easy approach if you not only make a single scan, but if you make a dual scan as some open source tools will do. For example, you can improve upon this. The disadvantage is, of course, then you have to scan your entire device twice, or you have to do it in a very smart way. And obviously, this will take you a lot of computation time. So that's something that you want to avoid. So what is the main point here? Well, it's basically the problem of solving some kind of jigsaw. So if you have all these different fragments, you have to solve the puzzle and making sure that each of the different fragments that you have for this file, that you put them together in the correct order. Okay, now let's go back to what we discussed already earlier, the problem with these PNG files that we noticed. You could say, so what? What does it matter that you have 1.7% of PNG images that may be incorrect? Again, it's the same thing. As already mentioned before, it will impact your computation time. Because why? Well, as I indicated, if you are trying to solve a jigsaw puzzle of all these different file fragments, then you may be looking to solve a very difficult puzzle if you are not aware that there are some implications or complications due to the fact that your base tool for checking if you have recovered some data correctly, if that is also not functioning properly. So that's the introduction part. Let's have a look now at the academic state of the art. Well, as I indicated already before, it's nearly impossible to cover it all, especially in a 1-hour presentation, I think, and probably you may have some much better or much more recent references, but I will just try to include some of them so that you may have a look if you are interested in this field. As I also explained already, I think it's not only about multimedia recovery. You do need some understanding of other fields that are related to digital forensics that are now increasingly related to big data and machine learning or artificial intelligence, robust hashing, etc. Because there is some integration going on between the low-level recovery and already more advanced functionalities, such as not just presenting to the user all the different photos that you have been able to find, but immediately sorting them, for example, if they are containing faces or guns, firearms, etc., those kind of things. And then let's not forget about forensic quality assurance and management. I will return to that later on, I guess, and some security, legal, ethical, and privacy issues, which are increasingly becoming important, and also some aspects from traditional forensics. Okay, so just a few important ones, in my most humble opinion, references. As always, you can find much more if you try to expand them or try to just search for them using any internet search engine. Okay. You may notice that I have not only included IEEE references. I did that on purpose because one of the points that I would like to make later on again, we'll return to that, hoping that we may all keep an open mind and be able to collaborate on some things. So these are just some indications of, let's say, recent, well, some of them are older than 5 years, but some interesting papers which relate to some of the work that I will discuss later on. So there's quite some work on JPEG file fragments and related things. Obviously, video is an interesting topic. And then, of course, you will also notice that there is some work that has been done on PNG recovery and other things. What is the thing that I do want to highlight here is that that some work exists that predates all of these references. And I may return to that later as well. But for example, the video free group, which I will talk about at the end, I think, already had its first meeting in 2006, discovering some of the law enforcement tools or methods that were being used to recover multimedia information. So this is one of the things that I will try to indicate a little bit later on as well. Okay. So you may also find that there is some emphasis or bias in this presentation towards JPEG and PNG recovery. Why is that? Well, basically because it's, as you all know, I guess, one JPEG is in particular one of the most often used file formats in our daily lives, I would say. And PNG is also still being heavily used on a lot of internet websites. And actually also a more detailed reason why we got into this area is that we run one of the, well, several actually, we ran several well-known open source or freely available tools on real case data. And we noticed that it was producing large number of false positive PNG detection results. So returning to a few slides earlier, we did not only get PNGs which were incorrect, which had all needed manual review, but we also lost a lot of information because we also found some very large PNGs which turned out to contain other files within them. So all these tools did not give us any good results. So we started working in this area to try to do a better job and having a better tool available to automate some things. Okay, and then let's have a look at some of the things that have been done at various law enforcement agencies or forensic institutes across Europe, mainly. So I will try to quickly explain some of these tools that I've summarized here, just an overview. So JLab, some PNG header repair, JPEG carve, PNG carve, and then some video stuff as well. I will also discuss a little bit the available commercial tools, but that's at the end. So let's first have a look at some of these existing tools. Now, actually, what I will not show you is the actual JLab tool, but this is a very old tool, and this is actually a tool that got me motivated to work in this area. What I will show here is a similar tool which works on GIF images. It's one that we developed together with a master student at Ghent University. And so what is the base idea is, well, if you have issues in recovering data, or if you have any data that has been corrupted, so malfunctioning USB drives, hard drives that have been partially repaired but are spewing out incorrect JPEG data, well, then you can still try to fix some of those incorrect files if you have a proper tool. And what does this tool do? Well, as you can see, it is going to just try to read in your file, try to decode it, and reconstruct a, let's say, syntax tree in which you can browse all the different elements that are in there. So you can quickly try to spot if some of these elements would be missing. If you know, of course, that they should be there, or you have the tool check if they are in correct order, etc., then you can already spot major issues with the file that you are trying to recover. But it's not only that, you can also do mouse over on some of the images so that if you click on a certain position on the image, that you will find the position where you are in the file. So small hex editor. Everybody's got a lot of hex in our field, although of course we try to move away from it by using automation. But the hex editor can be very useful to try to make some corrections or try to cut and paste some things so that you may still have a partial recovered file. So this tool, I think, was even before 2000, the year 2000. So they were already working on that. So it's quite a nice tool. Unfortunately, it's no longer being maintained. And I will return to that later too, I think. So this I already explained a little bit. And as indicated, so you can get some, you can manually do some corrections to try to fix the image. Of course, this is trial and error. And as I said, it is manual. So it will take some time and some understanding of the GIF format in this case, or the JPEG format in the JLab situation. But it offers you the possibility to do it and to do it in a visual way. So that was a very nice tool set to have handy. Something similar.
Sorry, it's 2:30, just to tell you.
Yeah, thank you. Yeah, I will try to speed up some more to try to stick to the time frame. Thanks a lot. So PNG header repair. Well, if you think about files being overwritten by other files because they have been deleted or you're just trying to destroy them on purpose for some reason, then obviously the most sensitive part of a file, in particular for PNG, is the header, because that contains all the information that you need to be able to decode a file. So what we worked on quite some time ago already was to try to repair those headers in an automatic way. So what you see here is just a similarity measure that's being computed for different configurations, bit depths, and color types of the images. And then the tool tries to estimate the size of the reconstructed image. So, of course, it assumes that all the pixel data, let's say compressed zlib pixel data is still correct. But if something's wrong with your header, this tool can help you in trying to still fix the image. And it just lists all the candidates. So you see that in terms of color, the top candidate with the lowest value, it actually is here the best one. And of course, we know this picture, and the second one is much better. So of course, the metric is an important component, and there are also some possibilities to continue working on that in the future, I think. Now let's look at the Jpegs. Now thinking again about this file carving problem. So if you have a multi-fragment file, as indicated at the very bottom, the question is, how can you know when you have to stop reading the data? So how do you determine the end of the first fragment? Because all this is binary data. And so you have to try to locate the pieces of the puzzle before you can try to put them together. Well, the first issue or the first possibility would, of course, be to try to just use a standard decoder and decode the image and see at what point the decoder would stop. So when does it throw a warning or an error? And obviously, if your decoding library gives you an error, then it's something, an indication that something is wrong. And you could say, okay, at this position here that you see at the bottom, I know something is wrong because my tool has stopped decoding. So that would be a first option to consider. Unfortunately, this does not always work. And so what can you do? Well, you can move away from the pure decoding or syntax domain, and you can start to try to look at actually the pixels that are being decoded. So typically, libjpeg, so for decoding the JPEG images, will deliver all gray values as soon as something is wrong. And then by just, again, trying to define a metric here, you can try to determine in a visual way, well, numerical pixel value way, where the error has occurred. And that's quite important because just to illustrate again, if you would have this image decoded by libjpeg, the decoder would only stop decoding at this point. So these windows in black are obviously zoom-ins. So although you see that there's a clear issue with the visual content of the image, the decoder will only detect it at the point where you are already past the real point where the actual fragmentation occurs. So that means that using this visual metric, if it works properly, you are able to much more accurately detect where the end of the first fragment would be, or the end of the second fragment, and then you know how to pick the pieces to solve the puzzle, let's say. So we did some work on that. This is published in 2016, if I remember correctly. I should quickly try to explain a little bit about all these numbers that you see here. So you see a different set of inputs, data dumps. So let's say copies of devices. They all have a name. You may know some of these acronyms. And what we experimented with is also providing information or providing no information to each of the tools that we tested for the cluster size that was being used by the file system. Which are the two tools that you can then see that we have tested? Well, this is our own tool, and this is APF, is Adroit Photo Forensics. So to date, this is the only tool that law enforcement is still using, which does a very good job in recovering JPEG pictures, but unfortunately, it's no longer being available. So it was based on some of the references that I indicated in the state of the art at the beginning of this presentation. Again, a very good tool, but unfortunately, it's no longer commercially available today. What can you see? Well, first thing is that you can see that our tool was able to always recover. Here is the ground truth column, and here you see the results of the files that are being recovered. Our tool was always able to recover all the files correctly, no matter what parameter we tried to force upon, or even if we did not provide a parameter on the cluster size that was used by the file system. And this is different, of course, for Adroit Photo Forensics. You see that here this parameter has an impact. So it means that either you have to investigate first what this cluster size parameter is, or you have to run the tool multiple times to try to get possibly the best result. And then, of course, another major improvement was the speed of the tool. We tried to focus on that with various heuristics and other tricks that we applied. But let's move along to PNG. In this slide, I'm not really going to focus on it too much, but the main point that we tried to make some advancement here is to recover also partial files. I'm not going to explain the techniques that we use to achieve this, but again, I think the most recent publication that we have seen is also indicated in the state of the art in one of the first slides of its presentation. But we already achieved much better results than a lot of other tools some years before that, in again collaboration with the thesis student. So how does this tool outperform? Well, we used the NIST computer forensic tool testing data sets as an input, and what you see in each of the graphs are different tools being tested. So we have NCase, FTK, PhotoRec, well, version at that time, of course, X-Ways, etc., all commercial tools. And then at the rightmost end of the slides, you see some of the results we were able to obtain. Unfortunately, this work has not yet been published. So again, we should also probably compare it with the work that has been published now by others, but that's something that's on the to-do list still. What is another important point that you may wonder about? You see different colors. Well, the different colors also indicate the bigger issue that we have in this field of multimedia recovery. I will probably also return to it very quickly later on. That is, how do you measure your performance of your tool? Because if you have a partially visible picture, how do you rate the quality of that picture? Do you only count the bytes? Or do you count the pixels, to put it very simple? Okay. Then let's move to Defraser. I hope you would all know this tool. It's been developed by our colleagues in the Netherlands Forensics Institute for quite a while, but unfortunately, the development plans that they have been put on ice, if I'm still informed correctly. And of course, the world of formats and codecs has evolved in the meantime as well. But still, I think Rickert, one of the main authors of this tool, has made a nice publication together with Ian Casey. And this is also an interesting paper to look at if you're interested in this tool. What does it do? It allows you to, again, scan a data dump, so a copy of a device, and it will show you both in terms of, let's say, bitstream syntax, as well as visually, some of the recovery results for video that you are able to achieve. It also allows interaction, so which makes that you can actually try to extract certain fragments of a video and immediately save them to a file or immediately play them as a sequence, not only just the thumbnails. So that is very nice and very practical. Unfortunately, it did have some issues. Let's not go into detail on that, but it was also an interesting tool to build upon. So the colleagues in Sweden, Swedish Polish, they did some work on this. So instead of trying to recover the entire video stream, they aimed at recovering just, let's say, the iframes, the main keyframes in the video. So the aim was no longer to try to play the video, but just to get an idea of what kind of visual content would be present in the video data that is still lingering on a device. So the idea, for example, an application is in child sexual exploitation cases. If you can demonstrate that there is evidence that shows that there are some questionable videos on a certain device, it can be already enough to take further investigative or legal actions instead of having to make an effort to try to actually play the full video. So they did some nice work on just trying to visualize then the results, even if some of the parameters needed for decoding were missing. And actually, they also achieved the best results, if I'm not mistaken, by using some machine learning techniques to try to, let's say, determine the parameters. So those tools mainly focus again on the, let's say, pixel domain or the coding of visual information. But of course, there's more to that. So again, the colleagues in Sweden, the Netherlands, and also in Germany, they did quite some work, mainly script-based or specific tools that they developed in-house on exploiting, let's say, the metadata that is stuck in containers around the actual pixel data. So I'm not going to go into detail there because that would be a presentation in itself, I think. So main points to take from this. Unfortunately, some of the results that I presented here, they are outdated. So you could argue that they always are. It's like writing a scientific paper. You never know that at the time that you submit it, that somebody else may already have submitted a similar idea to another conference or another journal and may thus be just in front of you in publishing this new method. It's a bit similar here, I guess, but definitely we should make an effort to try to update some of our results, in particular if we are comparing tools one against the other. The other thing I already mentioned that I think is that most of these things have been not very well disseminated. So this is also the reason why I'm happy to give this presentation today. I hope that it may be some new information for you, that this work does exist, and so that we should try to reach out to each other and make sure that we achieve some updating and dissemination on all this work and knowledge that exists. So this, I think I already highlighted. So collaboration, we're always looking for that, I think. Collaboration with companies, yes, very interesting, I think, and we already also at one point in time attempted that. But again, there's a risk, again, referring to the Edward photoforensics, which unfortunately had to cease operation. And then luckily, we do have some funding of R&D projects, which does allow us to continue to focus on some of these tools. If you would have any suggestions, yes, of course, they would be also very welcome. Another, in my most humble opinion, commercial tools, yes, there are too many. It's almost impossible to keep track of all the data recovery tools that we have, but most of them actually, I'm terribly sorry, but they are no good, because that's actually what we showed earlier, I think, in some of the slides, that, for example, on the NIST data sets, some of the tools will fail on, let's say, not obvious, but still relatively simple issues, complications that may arise. Another issue that we often encounter also, and it's in a way logical, but it's also a bit unfortunate, is that everybody's trying to really solve the same problem over and over again, hoping to arrive at one single tool that will do everything. And although it's obvious that it's not the good approach to take from a management point of view, it's also not easy to avoid it. So the big point that I want to make is that we do need tool testing, but maybe we should look into collaborating on that as a community as well. And actually, we already ran a project on that also in the European context. If you would be interested in that, please feel free to let me know. There's a reference at the end to that, I think, as well. Also, do not only focus on multimedia data recovery. As I indicated from the very beginning of this presentation, it's all interlinked with the base digital forensics methods. And again, the same problem there. We ran a proficiency test back in 2013 already on that. So again, maybe the results are outdated, but sometimes it's even only a very small, relatively unknown tool that will do a good job. So you see that tool here. This is just basic recovery of files at the file system level when there is corruption. I indicated that earlier. I guess that this is a big question still. Corrupted data, how do you handle that? Well, you see that that this tool is doing a relatively good job, while the perfect result is again noticeably different from what some commercial tools may achieve. Good. Then let's move on to relevance for forensic workflow. So this is a little bit a totally different part maybe in this presentation. I will try to skip forward a little bit on the first example.
Sorry, if you can close in 5 minutes so that we can leave some questions. Thanks.
Yes, I will try to do that. So I was going to make some comments about what is important to understand about forensic workflows. Well, one of the things is that it's obvious that you would like to extract all the remnant data that is relevant in any case that has some digital component in that. But of course, we do need automation for that. And in particular, as already highlighted before, we need also high quality results. Otherwise, we are never sure that we did the best job possible, which is often what we have to do as forensic investigators in real casework. So let's try to skip the rest of the slide. Also, do not be mistaken. There are some other aspects that may play here. One of them is that in real investigations, you may be ordered to do something which in fact you are incapable of doing. And some anecdote is that, well, at least in Belgium, an investigative judge who orders you to do something, he can do some real ordering about, so he can have you picked up by police to work on certain things, even at Christmas dinner and things like that. So that's what can happen in real life forensics. What is important to know is also that it's not only always about getting the best result possible as soon as possible. So, and that's an approach that works from two ways. You may propose or you may be requested to work in a phased approach. So try to get some results, some easy results as soon as possible, explain that there are more advanced options that are possible, and then move on from that. Well, in that same spirit, you may also target the development of a certain tool for a specific use case. With that, I mean, if you really have to recover as soon as possible results from a 2 terabyte disk, then obviously you're not going to scan every byte, but you're going to do some heuristics to try to get some results. And then as more time becomes available, you can try to obtain better results. So in the interest of time, I think I may skip this first case, which I was going to explain about child sexual exploitation material. As I already explained a little bit, is that sometimes we do have to cut some corners, but the important thing is always, I think, is to clearly document what are the things that you did, what are the things that you did not yet do, and what are the priorities on some of the work that you propose to do, if this is still possible. Okay. I'm sorry, I'll skip this. I'm not sure if and how I could distribute the slides afterwards, but if not through the conference, then please feel free to contact me at any point in time. Something else that has not been really looked into too much, I think, outside of actual forensic workflows, which could be an interesting avenue for future research, also in academics, is also to consider where certain data has been written on a storage device. So obviously, if you have two pictures that are being taken and the SD card on which they are being written is a new SD card, brand new, then obviously you should find these files in order, in time, and also in order in position on the storage media. So the normal file systems would not randomly write files on random locations. So that is something that you can check also in the context of image authentication or multimedia authentication in general. So from the digital forensics point of view. Yeah, this is another tool that is not yet fully disseminated on, I think. There is some work in this area, but the idea is also, again, the same as mentioned before, is that you do not only focus on what you have already done, but you also try to look at what you have not yet done. So a simple way of doing that is, if you know which files, which data you have recovered, you can simply plot them in an image. And in this case, the black pixels indicate positions on the storage device or the data dump in which you have not yet recovered any data. So then you know this is the space where I need to look for something more and try to do something special or more dedicated. So you can put that in a simple image, or you can try to implement a more interactive method for doing that. So I guess that's the most important about that. Okay, so again, maybe a hint for possibilities in terms of future work. It's not only about having a good tool or framework of tools, but you also preferably still need a graphical user interface, which will allow you to try to study and understand how some data or some data areas are remaining or have already been processed. Okay, so conclusion from this is that, well, every case, it could learn you something new. That's the interesting part, being stuck between academia and real life casework. I think it may deliver you new ideas on new improvements for tools and methods that we all need to handle these problems properly. Well, something that I'm not going to talk about too much, but something that may be also important for you to understand is that forensic quality assurance and QM, it should read, quality management is something that is impacting us throughout our work as in real casework. That is that we do need tools to be tested or actually validated before we can use them, in particular when you are producing evidence that's going to be used in court. If you are only going to look for indications that could help the investigation, so not the real evidence, but indication that this person was involved or not, this person may need further investigation or not, okay, then it's more from a strategic point of view. You could be flexible in using some tools, but if it's actually going to be a full depth proof investigation, be careful. In forensics, you do need to consider some quality assurance issues there. Okay. Then I had two more examples, one of them being image authentication. Well, it's not only thinking about the pixels in image authentication. So a case with document fraud, think about some of the other things being that you may need some base digital forensic skills to build a larger context around some of the data that you may find, and that may help you understand the entire case a little bit better. So if you wonder what this is all about, and maybe it's also a good idea to have a look at this recent document, which may help you a little bit to understand some of the context that we are in outside of just running filters and detectors for image authentication. And then, of course, a link to an ongoing project in which I hope you may have some publications or papers, presentations later on in the coming years in this conference, the Uncover project. So based on the need for creating new tools that would help us to fight the use of steganography in criminal casework. Again, how can we apply multimedia recovery in this? Well, this project has received some classification from the European Commission, so I'm not going to go into too much detail on that. But of course, if you are hiding information, then you have obviously a source image, the native image, and then the image that you produce with the hidden content in it. So if you are able to devise a tool that can help you locate both of them in an efficient way, then of course this may help you to find evidence in this kind of problems. Future work, very quickly. There are many possibilities for future work. I think main points are that many tools, as already illustrated in this presentation, do not always work as we would hope that they would work. So sometimes very simple things being used, which work very well, but not always. And we do want to go all the way if possible. We do need tool testing efforts. And we have a problem in managing all these different tools and all the different formats that are obviously there. I was going to return a little bit on the issue of hardware repair and recovery. What is the main point here? No details to save time. As I explained at the beginning, the point is that in hardware repair and recovery, you may introduce errors into your data, in the binary data. And so most of the traditional tools that exist and methods that exist, they cannot handle that. So even if a single byte flips, immediately you will see that the tool stops working. And obviously we could do a better job in trying to find robust ways of handling that. So some amateur philosophical notes to finally conclude it. Please keep an open mind. It's a very general comment that anyone can state at any time. But my point is, let's try to collaborate. Let's try to think also outside of our own working environments, try to keep an interface between the two sides of it, so academia and strict, simple, single button click law enforcement, and try to reach out also to other subfields that are related, also including security, ethical, and legal privacy issues in general. So if you would be interested to join the ENSFI activities, there's this conference coming up next year, COVID permitting still, but it's a very big conference and it's a triennial conference. And you may be able to discuss some of your methods or work there, because there is one of the sub-teams is on anything that's digital. So feel free to join us, or feel free to join one of these working groups, which traditionally have law enforcement agencies and forensic institutes, but of course we are open also to collaborate with academia, industry, etc. So a big thank you to this ENSFI Video Free group, which I mentioned earlier has been active since 2006 across Europe, and also interest from across the globe actually. There's some information about the projects that were linked to this presentation. I want to thank NIST for their very nice work, still continuing on what they are doing with tool testing, and all these persons who did some of the real hard lifting work that yielded all the results in this presentation. Okay, and that's it. I'm done, I think, so I'm open to your questions. I will stop maybe the PowerPoint presentation so I can have an overview.
Yes.
Of the...
Thank you. Yes, I think we can have time for a couple of questions. Are there any questions on site?
No questions, or are you passing on a microphone?
Yes, there are. Yes, they're passing the microphone. There is some problem with the microphone. And if there is someone online that also wants to put a question on the chat, I can read the chat to the speaker.
Okay.
So we have a question, but we have some problem with the microphone.
Yeah.
So okay.
Yeah, thanks for the inspiring talk. You mentioned that quality assurance is very important, and particularly if you want to use a forensic technique for a court case, are there any like legal compliance requirements for file covers, and especially also for these digital forensics areas that are not that are very recent and where there's not so many ISO norms yet?
Well, if am I muted? I hope not.
No, I can hear you.
Okay,
No.
that's fine. Well, the first part of the question is on the carving. Actually, I have never yet seen any questions related to that. So from the legal point of view, so most institutes also or police laboratories that are working on this, they just use the tools as they are and they present their results. So you could raise some issues about that. And the main point, I think, is that if there is any doubt about these results, then of course you need to be able to open your case for a cross-examination, let's say, to have them, the results that you presented, to have them reviewed by another expert or party to make sure that what you produced is indeed a correct result. Maybe that's not the real answer to the question, but indeed it's a valid point. You know, in the US, there is always the Dobert and Fry thing that is very important, and also in Europe and elsewhere in the world. But that's exactly the point. We should have a database of tool testing results that would give us an indication of how reliable some tools are, where they fail and where they work properly. And that's something that is not easy to solve, but that indeed we would need. The second part was more general in your question, I think, but maybe you can elaborate a little bit on it.
Oh, I just thought that yeah, file carving is maybe well developed or has been known over the last years already. But if you think of more forensic tools to come, maybe some more sophisticated tools that start to use machine learning, is there any way we can get these to use also in court cases, or would we need to have more like standards that tell us what tools can be reliably used and how tools can be made more reliable?
Mm-hmm. Yes, well, anything that's related to machine learning or, well, artificial intelligence, if you like, but that's a philosophical discussion as well, I think, on using that term. It's very sensitive. And so actually there are now, I think, in parallel, 3 European research projects running on that to look into not only the technical developments, but in particular also these issues that relate to security of those tools. So how to manipulate possibly some tools to attack them, and also the ethical and legal issues related to that. Is there a clear answer to it? Not yet, I would say. And for the moment, I do have the impression that many of my colleagues have the attitude of don't touch. If it is really going to be presented in court, the main question, as you know, still, although there's very nice work on that, is explainability. How can you explain how a certain tool does what? And if then some legal challenge would come up, as we have already seen, with showing that a cat would be identified as a dog by some machine learning algorithm, with adding little noise to the image, of course, a specific noise, but still, then this could create quite some issues, I think. So we have a lot of road to travel there, but it's in progress, and let's hope that we can come up with a solution for that.
Thank you.
You're welcome.
Okay, there are no other questions online, so on site, there are other questions?
No, I think at Montpellier we don't have no more questions, Alessandro.
Okay, so just one short question, so just to close. Is there any preliminary study on file carving on new image formats? You told us that now there is PNG and Jpeg because they're more diffused But is there anything preliminary?
From inside my context, no. I know that some colleagues have worked on some very specific cases, but not in the sense that they think this would be a tool that they would like to share with others, and not in the sense that they, at a much bigger distance, as already indicated earlier, also not in a sense that they would consider publishing about it in any near future. So that's indeed a valid point. There are definitely options to explore different file formats, and some work has already been done as in trying to do more generic things. But I have the impression that this did not materialize into really actual tools that are usable or that have been used by somebody else. So the idea, for example, would be there that you have, from a conceptual point of view, you always have the same issues appearing. You have a fragmentation point, you need to detect the endpoint, so the end of the fragmentation point, and you need to have some generic operator that is able to validate across that fragmentation point and things like that. So you can try to make more abstract reasonings about that for different file formats at the same time. But still, it would then require you to do some additional coding in a way, or crossing the boundary between, let's say, the abstract level and the more practical format-specific level.
Okay, thank you very much. Okay, I think we have to close the session because the social event is waiting for the people there. So thank you very much to Patrick. And
yeah, I was most happy to do so. Sorry I had to rush, but with the time shift, yes.
Yes,
I wish you all a very pleasant stay, those of you who are in France, and I hope that we may meet again in the future in some way, and please feel free to send me email questions or comments if you would have them.
So thank you very much. Bye.
You're welcome.
Thank you,
Bye-bye.
Patrick, and thank you, Alessandro, to have accepted to chair this keynote. So thank you. Bye.
Bye.
Bye-bye.
Ciao.
To close the